like, share, and subscribe to my YouTube channel. Thank you for your support. For this video today, we are going to discuss the exercises for chapter 4. Okay? So yeah, as the same as usual, these first few questions are from the Coursebook. Alright? So let's take a look at the question 1 first. Write each of these angles in radians, correct to 3 significant figures. So, you need to know about the relationship between the conversion of angles from degree to radian, right? Let's say in theta. Okay, what is the relationship? From degree to radian, just times pi over 180. Okay, then if you want to carry out the reverse process, you just multiply back 180 or over pi, or divided by pi over 180. Okay, so use this relationship to convert each of these angles from degree to radian. Okay, so how does it carry out? So it's just basically multiply these angles in degree by pi over 180 to get the angles in radians. Alright, so this is indeed crucial for you because this concept may uses related to other topics such as trigonometrics. Okay, so what are you going to do is just multiply pi over 180 to get the answer. Okay, remember to leave each of these angles in 3 significant figures. So for the part A, you will get 0.489. Okay, this one must be accurate answer. Because candidates should follow the standard answer from the requirements of the instructions. Okay, and carry out the same way, I mean the same step as for the other parts. Okay, so let me replace and repeat my words. Just use the same method as A to answer each part of these angles, okay, for the conversion of the angles from degree to radian. So I'm not going to write the steps over here. Okay, I just give you each of these angles in radian after the conversion. Well, actually, in the external exam, when it comes to the answer of the angles in radians, it is optional for you to write the rad or without. But it is best for you to write the rad, okay, as the answer of the angles in radian. Okay, so which means it is clearly stated that your answer must be in angles, but in radians. Alright? Okay, so I have written all the answers below here, but as you can see that there are two different answers, I mean different quadrants. Okay, so as you can see that for the part D, it has 200 degree as well as E 320 degree respectively. Alright, so no worries about it is not an accurate angles, but this question only wants you to convert these angles in radians. Okay, So as long as radians must be in positive angle, right? In the anti-clockwise. Okay? So I hope you clearly understand about this. Right? So that's the end of discussion for this question. Alright, for question 2, write each of these angles in degrees correct to one decimal place. Yeah. So for the question 2, it is basically just carry out the reverse process from the question 1, from the previous one. Okay? So now, given that you are having given there's angles in radian, you just convert back to degrees by multiplying 180 divided by pi, or divide by pi of 180. Okay? So what are you going to do for these questions? Just multiply each of these angles by 180 over pi. Okay? Following the relationship stated just now. So 1.2 radians equals to 1.2 times 180 divided by pi. So remember to leave your answers of angles in degree in one decimal place. So candidates should get used to it, about the habits of leaving the angles in degrees. Okay, since the angles are in degrees, so we have to leave it in one decimal place. So this is the standard one, standard instructions. I mean the standard requirements of the answers of angles in degrees. Okay, for each external examinations. All right. So what about, let's solve the B, C, and D as well as E. So just multiply all of these angles by 180 over pi. That's enough. Okay? So you don't have to further investigate why does this relationship come up. Okay? Okay, that's correct. So yeah, okay. So for each questions in when you are doing the external examination past years, you have to leave your answers in degrees. Okay, if any, in correct to one decimal place. So this is always the standard requirements for, you can see through the instructions. Okay, so usually it shows in the instructions for each passing papers. All right. So yeah, that's the end of the discussion for question 2. Okay, let's move on to the next question, which is the question 3. So this question is also from the Coursebook. Okay, find in terms of pi the arc length of the sector. In terms of pi, this tones gives us a prompt that you need to leave your answer in the exact form with the term pi. Alright, let's say your answer is a pi. So where a is regardless integers or other forms, but just that it can't be decimal, right? So this is the prompt for you. The arc length of the sector. Okay, what is the formula of arc length of a sector? Recall that arc length is S equals to R theta. Okay, you must remember this formula. I think you should have a core and solid knowledge from the secondary school. for recognizing this formula, right? So let's solve for the first part A. So it's basically just use the formula. R is your radius, theta is the angle in radian. So we have 8 and pi over 4. Multiply these two together to get 2 pi. Okay? And it is best for you to leave your answer with the units, but it is optional for you. Okay? The answer with the unit is optional. Sorry for my repeat. Okay? Because I want to emphasize that as long your answer is correct when you are dealing with these basic questions. So do carry out the same way for B, C, D, the rest of the parts, which is basically multiply radius by angle, provided the angle must be in radians. So B, you will get 3 pi. C, you will get 6 pi. And finally for the D, you will get 28 pi. So you may verify the answers for each part. Okay, so by right, the coefficient of the pi must be in integer. Alright, you may verify and see if you wish. So that's the end of the question. Alright, let's move on to the next question, which is the question 4. It's also from the Coursebook. Alright, so from this question on, we will discuss the complex question of the circular measures among the pure mathematics one. Alright, okay, let's begin. ABCD is a rectangle with an AB of 5 cm and BC 24 cm. Okay, let's absorb the first information. AB is 5 cm, means that parallelly CD is 5 cm. Since ABCD is a rectangle, okay, rectangle is a quadrilateral. And BC is 24, means that AD is also 24. Alright, okay. O is the midpoint of BC. What does it mean? It means that O divides B and C equally, means that this and these sides are equal in length. So 24 can be divided to 12 for OB as well as OC 12. Okay? Next information. OAED is a sector of circle with a center O. Okay, means that this is a center and these are the sector. This is a sector. Okay? Respective to this angle. Alright? So for the part A, find the length of AO. So as you can see that in the row of the sector, AO and OD are all radius. Okay? Their radius are equal. The radius is equal or constant. So let's label AO as R. Okay, the theta as, the angle is theta. Okay, so since the length of AO is a radius, and if you remove away the triangle, so what is the structure? What does the structure of the triangle look like? It looks like this. So here is your 5 with a right angle, of course, and this is 12. I want to find the R because the R is AO, right? So to find the R, we can just use the Pythagoras theorem to looking for the AO. Okay? So for me, I would directly write AO squared equals to 5 squared plus 12 squared. 12 squared. Yeah, sometimes apologize to my pronunciation, right? Sometimes my words are not always fluent as you thought. Okay? So if you finally you evaluate AO as 13. Okay, it's an exact integer value. So for me, I recommend you to write AO in the CM since the first part asks you to find the length. Okay, so let's proceed to the next part. Find the angles AOD in radians. Alright, so angle AOD is basically the theta that I label over here in the diagram. So how to find? Okay, so what are you going to do is to remove this isosceles triangle away. Why do I have to say it is isosceles triangle? Because two sides are equal. Okay, where an isosceles triangle inscribes inside a sector. Alright, where this isosceles triangle is bounded by two radius and a chord inside the sector. Okay, so the length of the chord is 24 inside that inscribes inside the sector with the two R's. Okay, where the R's is the AO 13 that we have found. And what is theta? Theta is the angle AOD we are looking for. So instead of putting the theta, let's change it to the angle of O. So you have given three known sides but with an unknown angle. So we have to use the cosine rule. This is the only solution to lead to the answer of the AOD. So use the cosine rule of the length, the square of a length which is opposite to the angle equals to the sum of the rest of the two sides, the square of the rest of two sides, and subtract the twice of the 2 times 2 sides and the cosine of the angle. Okay, where the angle is in radian. So remember to convert this theta into the radian form in your calculator. This one I will perform the guidance in another shots. Alright, separately. So the cosine of the O is 24 square minus 30 square minus, sorry, this is plus, minus 30 square divided by minus 2 times 13 times 13. Okay, so now evaluate it. What will you get? Eventually you will get 2.35 radians. Okay, so any value which is not exact, leave it in 3 decimal forms. For angles, leave it in 1 decimal place. This is the standard instructions for each external exams. Alright, so yeah, I need to notify you that from now on, the question which needs to use more spaces, I can provide for you. I can provide more space for you to work your solution easier. Alright, so let's move on to the C. Find the perimeter of the shaded region. Okay, for your understanding and to reduce your confusion, so I need to rub these notes away for your understanding. Okay, the perimeter of shaded region means the perimeter of the sector. Okay, how to find the perimeter of the sector? This is your S, this is your 2 radius, so means that the perimeter is just basically R plus S, right? As you know, the formula of S is R theta, so R plus R theta. Okay, where the theta is the angle of O, Well, it's best for you to leave your um, write the more accurate value of the angle of the O for the accuracy answer. Okay, so you approximate it as 2.3520 if you wish. Okay, so it is the best recommendation for you to leave in the decimal value which is usable for the next subsequent parts. I mean the next dependent parts in 5 significant figures. This is the best recommendation for you. Alright, so the R is 13 and your angles is 2.3520. 13 plus 13 plus 13 of 2.3520, and use your calculator to calculate the final answer of the perimeter of the sector. So eventually you will get 56.6 cm. So that's all for this question. Thank you. Alright, let's move on to the next question, which is the question 5. It's also from the Coursebook. Alright, refer to this diagram. It shows that there's a semicircle with the radius of the 10. So the radius of a semicircle is illustrated over here, which is OA is 10, as well as OB 10, OC 10. Alright, the angle BOC equals to theta radians. The perimeter, okay, here is a radians. So means that, yeah, sorry, I need to finish the reading of the questions. The perimeter of the AOC, okay, this perimeter is twice of the perimeter of BOC. Okay, means that this total perimeter is the two times of the perimeter of the OBC. So what should I do? Okay, actually these sentences gives us the prompt and is to help you to answer the part A, since the part A wants you to show that theta equals to pi minus 2 over 3. So it is as exact values but in terms of pi. So I believe theta is in radians. So how does it lead to this answer? Okay, let's solve for A. So let's label perimeter of the sector, let's say PAOC. Twice of the perimeter sector BOC is the 2 times of the PBOC. Alright, so how to get a perimeter of the sector? So it's just basically twice of the radius and the arc length, right? So I don't think I'd have to write 10 times, since each term has the term radius, right? So instead I just leave it as r, which is 2r plus r theta, but the theta is not theta, this angle, okay, because a semicircle has the angle subtended of 180 degree, but 180 degree is in degree. Okay, so we need to convert it to the radians. So 180 degree is pi radians, so means that this angle is pi minus theta. Okay, of course it's in radian, equals to 2 times of the twice of the r plus r theta. Okay, which is the twice of the sum of these two radius and the arc length BC over here. So this time angle, the arc BC is dependent on the theta. Okay, the exact theta. So as you can see that each term contains the r, so means that we can cancel the r out. Okay, now the next step is to expand and simplify it. Okay, that leads to your answers from the question. So I have 3 theta equals to pi minus 2. Okay, divide 3 at both sides of equations, so we get theta equals to pi minus 2 over 3. Yeah, that's correct. Make sure all of our workings are valid and correct without any reckless mistake. Therefore, shown. Okay, so if you do until here, congratulations, the marks might allocate 3 marks, up to 2 to 3 marks. Okay, if you are able to solve the proof questions. Okay, hence, find the perimeter of the triangle ABC. Okay, triangle ABC, so means that we can draw a scalene triangle, and I may erase this away by using the stroke. To reduce your confusions. So, given that AB is 20 and is also diameter. So as you know that diameter is the twice of the radius, is 2 times 10, 20. So AB is 20. Okay? So how to get BC and AC? So if you realize that actually BC is the length of the chord that inscribed inside the sector. Okay? Now I don't want to, let's ignore it is a semicircle. Let's focus on this sector. I mean the length of the chord that inscribed inside the sector OBC. Okay? So yeah, apologize to the laser. Okay? It's quite chaotic. So OB is a radius as well as OC, 10. So how to get the BC? As you can see that there's a isosceles triangle, but we still need to use the cosine formula to looking for the length of chord as well as the another length of chord AC. Okay, so for the part B, you have to use the cosine rule. What does cosine rule state that? It states that BC square equals to, okay, I mean this length is opposite to the angle, equals to the sum of the squares of the rest of sides inside for a triangle, which is 10 square plus 10 square minus the twice of the 2 times the product of 2 sides as well as the cosine of the theta. So use the result from A, as you know that the theta is pi minus 2 over 3. Okay, so means that the workings of for the part B is dependent on the part A. Okay, so in case you are not able to answer the part A correctly, if you have any mistakes in the for somewhere the steps in the part A, you can use the results of the A directly to answer the B. So this is the advantage. Okay, to make sure you are not losing the marks too much. Okay, that allocates in the respective parts of questions. So yeah. So which is 10 square plus 10 square minus twice of the 10, 10 cosine of the pi minus 2 over 3. So as I said, if you are not able to get an exact value in the middle of the steps, somehow the steps, okay, leave the dependent numerical values into the 5 single figures to maintain its accuracy for the final answer. Alright, So use your calculator to press it correctly of the cosine rule. So for the BC, I should get 3.7824. Okay, so this is the first step. Carry out the same steps for the length of the chord of AC. Okay, and next we are looking for the length of the chord AC before calculating the perimeter of triangle ABC. Alright, so which is AC squared equals to 10 squared plus 10 squared. Okay, 10 squared plus 10 squared minus 2 times 10 times 10 cosine of what angle? Okay, so you must dependent on the opposite of this length, the length of this, the angle of this length. Oh, sorry, I need to rephrase my sentence. It means that this angle is dependent on the opposite angle of the length of this, the length of AC. So therefore, this angle is not theta directly. However, is pi minus 2 over 3. Okay, so you can directly use your calculator to press for the exact value for the pi. So I can directly write it over here. Sorry, pi minus 2 over 3. Okay, if you wish. So for the desired workings, I may leave the angle inside the cosine as the exact form before the evaluation of its decimal value of length of AC. Right? So yeah. So I should get 2 pi plus 2 over 3. Right? And okay? Particularly, you will get AC as, just press your calculator, 19.639. So yeah, it makes sense. As you can see that it seems like AC, the length AC is almost the same as the AB, because they are both enough long. So now it's time for us to find the perimeter of the triangle ABC. Wow, finally, we're almost there. So to find the perimeter of ABC, just sum of these three lengths, which is 20 plus 3.7824 plus 19.639. So it's just perimeter of triangle ABC is just basically the sum of 20, this and this. So eventually you will get the final answer of 43.4 as your final answer, and it's optional for you to write the units, but for me, I wish to do so. Yeah, that's the end of the questions. I mean the discussion of this question. Okay, let's move on to the next question, which is the question 6. It's also from the Coursebook. Alright, refer to the diagram. It shows that there's a sector of the POR over here with a radius of 8 and the sector of the pi over 3 radians. Okay, of course shear wheel with the center O. And the line QOR and QR are perpendicular. So what does it mean? It means that this angle must be a right angle. So therefore, fundamentally, this triangle OPR is a right angular triangle. Okay? OPQ is a straight line. Yeah, the straight line of the diagonal of the right angular triangle. So, for the aim of this question, it wants you to find the exact area of the shaded region. So yeah, that's easy. How to find the area of the sector? How to find the area of a basic triangle? This one you should know from your secondary school. So it's just basically, what is the area of the shaded region? Let me abbreviate shaded region as SR. Okay, for your understanding. So area of the shaded region is the area of the triangle minus the area of sector. Enough. That's all for it. Don't think it complicated. They have to make yourself a difficult candidates. So what is the area of the triangle? Which is the half of the base, times base and height. So what is the base? Okay, so how to looking for the QR? So using the trigonometric ratios that you learned from your secondary school, which is the tangent pi over 3. Okay, so QR is literally 8 times tangent pi over 3. Alright, so make sure the angle is the units of angle must be converted to radians, as you are using the calculators to calculate the areas of the triangle respectively for each term. So your height is 8. What is the QR? QR is the derivation of here just now. So just use the result from your derivation. So the question wants you to find the exact area of the shaded region, right? Minus what is the area of sector, which is half r squared theta, right? So what is the exact value of pi over 3? So as you converted pi over 3 radians into the angles in degree, it is 60. Alright? So what is tangent pi over 3, which is sec 3? Okay? So let's perform the step slowly to reduce the careless mistake. So you will get 32 sec 3 for the first term minus the half of the 8 square pi over 3. So which is 32 over 3 pi. So it is fine for you to leave your exact area of shaded region in this form. However, instead I can leave it to another form. So as you can see that there's a 32 in the common factor of 32 for each term. So why not we are factorizing out to make it nicer for the answer. Okay, so I may factorize 32 over 3, and this you will get 3 sec 3 minus pi. Okay, you can leave it in the second form. So as long the exact form of the shaded regions could not include the decimal. Okay, even you convert this into the decimal is also not acceptable according to the standard marking scheme. Alright, so yeah, that's the end of this question. I mean the discussion of this question. Alright, let's move on to the next question, which is the question 7. So from this question on, it will be the challenge questions all the way to the end of this exercise chapter 4. Okay, the diagram shows a sector. Okay, this sector EOG of a circle with a center O. Okay, and it is not necessary say that a circle represents, it shows the full circles. Okay, it means that the sector EOG can be formed a circle. with a complete visualizations. Okay, and given there's a radius of r, line GF, okay, this is the GF, is tangent to the circle. Yeah, that's right. So it prompts you that the OG is perpendicular to the GF, alright, and where the E is the midpoint of OF. So in a center of circle, the radius is always constant, so the OE is R as well as EF is R. Okay, the perimeter of the shaded region is P. So what the perimeter shaded region is the sum of these three lengths. Okay, and arc length, length GF, and the EF, which is R. Okay, so yeah, okay, because the question wants you to prove that P equals to this particular result. Okay, of course it's in the exact form, so you can write out the work out the steps, which is P equals to EF, the arc length of the GE, okay, and the length of GF. Okay, before you find the arc length of the GE, what is the essential part that you need to find? Okay, which is the angle. So you will notice that it does not give you an angle in radians, so we have to find it out by ourselves. So since this is the 90 degree, okay, so there's a right angular triangle of the OGF form over here. Alright, following the properties from the question given. So you have to use the relationship, label this as theta. Okay, what you have? You have the adjacent, which is the ROG, as well as the OF, which is the twice of radius 2r. Okay, so you can state that tangent theta equals to r sorry, not tangent, is cos. Okay, because of the ratio of the adjacent side over the hypotenuse. Okay, so there are two r's. You can cancel the r's as a common factor. Okay, so you have cos theta equals to half, but given that the theta must be in radians to get the arc length easier. Alright, so take the arc cos at both sides, so you will get pi over 3. Okay, because of it is 60 degree. Yes, correct, it's 60 degree. Right? So how to find the GF? Okay, recall that this is the right angular triangle for the OGF. So to get the GF, you have to use the Pythagoras theorem. Okay, let me draw out the triangles for you as for your understanding. So given here is the arc of the sector, and here is the R, as well as here is your R to sum it up to get the 2R for the OF, and I want to looking for the GF. So we can use GF equals to square root of 2R square minus the R square. So we have 2R square minus R square, you will get R square. So means that sorry, you need to square the 2. So 4R square minus R square, which is 3R square. So for the GF, you will get R sub 3. Okay, we must assume that the R is positive. You must let the R becomes positive in order to calculate the perimeter of the shaded regions. Okay, logically the perimeter must be positive, as well as R is positive. Okay, so you'll get GF equals to R square root of 3. Alright, so where is your R? This is your R. Okay, where is your EF? It is R. What is the arc length of GE? R theta, right? So r times the pi over 3. Where is your GF? R sub 3. Okay? So, as you can see that there are 3 common terms, which is r, and following the answers shown over here, it wants you to factorize the 1 over 3. So, to do so, you have to factorize r over 3 for all terms. So, which is r over 3, the bracket of 3 plus this is the pi and the 3 sub 3. Okay, and if you leave your result of answer in this form, I would say it's correct as long it is equivalent or equivalent to the answer shown over here. So until here, you can just only write a word shown, okay, to prove your workings. Or in advance, you want to make it perfect by rearranging the terms that is exactly the same as the answer shown over here. Yes, you may. You can do it. Go on. So you can leave it as r over 3, the bracket of 3 plus 3 sub 3 plus pi, and it's shown. Okay? Alright. So yeah, let's move on to the part B. Okay, part B is about the area of the regions. Okay, represents A, and to show that you need to show the equation of the A in terms of R, right? That is stated over here. So you have a triangle, triangular triangle, as well as the sector. So the area is the area of the triangle minus the area of the sector. Okay, so how to find the area of the right angle triangle? So you have, for the GF, you have r square root of 3, correct? So the right angle triangle areas is half times base times height. Okay, so we have half of the r times the r sub 3, and then minus the half of the, okay, remember you must use the area of the sector, half r squared theta. What is the theta? Pi over 3. Alright, so evaluate it. You can evaluate until this kind of form. So as you can see that there are the common terms of the r square, factorize the r square out, and as you can see that the answer shown over here must factorize the 1 over 6, okay, as well. So factorize the r square over 6, so you'll get 3 sub 3 minus the pi, okay, and you may verify your answers with the answer given again, and if correct, just put the word shown. So there it is. Okay, so I feel like this question, the proving question, is quite direct from the Coursebook. Alright, so yeah, let's move on to the next question. Alright, here is the next question, but this is the first question of the passive questions among the exercises for chapter 4. Okay, so you may check that this is the 9709 May June 2008 question 5 from paper 1. Okay, so I'm not going to read through the questions, the statement of the questions over here, because it's basically, this statement is basically it's basically paraphrase the diagram. Okay, so yeah, so given the radius is OP and OQ, which is equal in length. Alright, so yeah, find the perimeter of the shaded regions. So you have the 5 and 12. So you need, in order to find the arc length, you need to find the angle first. Alright, so what is the relationship? You have adjacent, you have opposite, opposite over adjacents equals to the tangent theta. Okay, this is the trigonometric ratio definitions. We will proceed this in the next video. Alright. So if you want to leave your exact form, you can do it so. So you have theta equals to arctangent of the 12 over 5. Alright. And how to get the QT, which is the square root of to get the QT, you must find the hypotenuse and then subtract by 5 to get the length of QT, right? So you have 12 square plus 5 square. This is the length of the hypotenuse, and with the minus of 5. Okay, because you just want to find the length of QT. Alright. So calculate and see how much you get. You get 8 exactly. cm. So now you have the angle, you have the radius, you have the 12, as well as the length of QT that we have determined just now. So it makes your job easier to find the perimeter of shaded region. I just write the perimeter of the shaded region SR, which equals to length of QT, PT, and the arc length of the PQ. So what is your QT? 8. PT, 12. What is the arc length of the PQ? Which is the radius times the angle, right? And just press your calculators to get the decimal values. Since the arctangent, we are not able to find the exact form of the arctangent 12 over 5. Remember to convert the angle unit to the radian. Okay, since we are using the formula of the r theta. So by right you will get 25.9 cm. That's the answer. Okay. So let's move on to the part 2. Find the area of the shaded regions. Okay. So did you aware that the format of the questions is exactly the same as the previous question, right? So just use the same strategies to get the area of shaded region. Okay. So it's just basically the area of the triangle deduct by the area of the sector. So how to find the area of triangle? Half times base times height. What is the area of the sector? Which is r squared theta. Half, what is r? The r is 5. Also 5 squared. What is your theta? Arctangent 12 over 5. If you want to leave your answer in the accurate values. Alright? So we have 12 times 5 and the half minus the half of the r square, 5 square. What is the theta? Arctangent 12 over 5. So you will get 15.3 cm squared. Okay, so it is best for you to leave your answer of area and perimeter in their particular units. Alright, so that's all for this question. Let's move on to the next question. Okay, let's move on to the question 9. So this is also the puzzle questions, which is 9709, May June 2007, question 5 and paper 1. So these drawings is for your understandings, okay, that is analyzed from the question over here. Alright, so find the exact length of the AX. So how to find the AX? Okay, so since the A is the point of contact, which AX is tangent to the curvature of the circle AB, arc AB. Okay, so where A is the point of contact and this is a 90 degree. So if you demolate the triangle outside, okay, So here will be your triangles, and I'm going to rewrite the informations. So here is your pi over 6, because you divide this by half, right? And here is the 12, and ax. So what do you have? You have the opposite as well as the adjacent sides, right? And that is respective to the angles. So you must use the relationship of the trigonometric ratio tangent. Okay, Tokaso method. So the tangent pi over 6 equals to the ax over 12. And remember the exact length. See the word exact. That prompts to you that uh, the answer of the length of ax must be in the third form. Okay? So evaluate tangent pi over 6. What is it? It is basically tangent 30, right? Which is sec 3 over 3. Okay? So you can see there's both side. The both side of these numbers are the factors of 3. Cancel the 3 and cancel the 12 to the 4. Move the 4 upwards to get the exact value of the length of ax, which is 4 sec 3. And it is best for you to write cm. Okay, there it is. And make sure your answer must be in terms of the sec 3. So if you fulfill the requirements for the question, congratulations. Alright? So let's move on to the part 2. Find the area of the shaded regions. So how to get the area of region over here? So it's basically, so as you can see that these two triangles are congruent and identical, right? So which is basically the area of the shaded region equals to the twice of the area of the triangle, since the two triangles are identical and congruent. Deduct away the area of the sector ABO, right? So to get the area of the triangle, which is the half times base times height. Well, how to get a height? Okay, so the height is the length of ax that we have evaluated from A. So this is 4 sec 3 as well as bx is 4 sec 3. Okay, so you have 4 sec 3. Okay, given that the area of shaded region must be in terms of pi and sec 3 that the examiners expect for each candidates. Deduct away the area of sector, which is half. What is r squared? 12 squared, right? And pi over 3. So you have you cancel away the 2. Okay, 12 times 4, which is 48 sec 3, and the half of the 12 square divided by 3, which is minus 24 pi. Okay, so it is optional to leave the area of shaded region in the form of unfactorized, or you can factorize the 24 outside, since the 48 and 24 have a common factor, right? So you may factorize the 24 outside, so you will get 24 times the bracket of the 2 sec 3 minus pi. It's also acceptable as long these two answers are all equivalent, or maybe any other forms, but however you can't leave your answers in the decimal forms, okay, as this will deduct your accuracy mark. Alright, so yeah, it comes to the end of the discussion for this question. Let's move on to the next question. Okay, let's move on to the next question. This is also from the past questions, which is 9709, October, November 2008, question 6 from paper 1. So let's analyze the diagrams, okay, and compare to the statements stated over here. So the diagram has a circle with the center O and the radius of 5, so means that OQ must be 5 cm. The point P and Q lie on the circle, okay? So where P and Q are the all point of contact where it's tangent, where the lines are tangent to the circle. Okay? And the arc length of the PQ is 9 cm. Alright, the tangent to the circle at P and Q meet at the point T. Okay, as the two tangents intersect at point P. Point T. Sorry, apologize about it. Okay, calculate the angle of POQ in radians. To find the angle over here, what should you do? It is definitely very easy because you just need to use the formula of S equals to R theta. Okay, where the S is arc length, which is 9. What is the radius, which is 5? And theta is the angle of POQ that we want to looking for. So you can leave in the fraction forms, radians, okay, or in decimal forms, okay, which is 1.8 rad. So that's all for this question, for the part of this. Okay, let's move on to the next part. Find the length of the PT. Okay, to get the PT, so you must know the some properties of the two tangents, which is two lines which is tangent to the circle and they meet at the point. So what I'm going to do is to draw a axis of symmetry. Okay, as you can see that it divides into the two congruent and identical triangles. Alright, so originally the POQ angle POQ is 1.8 rad. If you divide by half, you will get 0.9 rad, right? And I want to looking for the length of PT. What should I do? Okay, let's remove the triangle. Okay, you can try to visualize. So here is a right, there is a right angle. Alright, and here is the 0.9. So what do we have? You have the reference angle and the adjacents. So I want to find the opposite, right? Where opposite is the length of PT. So you need to relate the trigonometry ratio, Tokaso, but the most suitable one is TO, because of TOA, DOA, because tangent of the angle equals to the opposite over the adjacent. So the PT equals to the phi tangent 0.9 rad. So remember to convert the angles you need in your calculator into radian form. So you have phi tangent 0.9, you will get 6.30 cm. Okay? And let's move on to the C. Sorry, it's third part. Find the area of the shaded region. So how are you going to calculate the area of shaded region? Okay, so it's the same technique. The area of the twice of the triangles minus the area of the sector. Okay, area of shaded region is twice of the area of the triangle minus the area of the sector. So okay, let me move this to the other page. Okay, 2 times the half of the base times height, okay, minus half r square theta, 1 over 2, what is r? 5 cm square, 5 square, and 1.8. Okay, so if you want to maintain the accuracy for the PT, you can prepare the values of PT if you wish. If you wish to let the answers for the third part, which is carry forward the previous part accurately. So to maintain the accuracy, you can leave it in the 5, at most 5 significant figures. Okay. So you will get 9.00 cm square. Okay, that's the area of shaded region, and we have ended the discussion for the question 10. So let's move on to the next question. Alright, let's move on to the next question, which is the question 11. So which is the 9709 May June series 2003 question 9 from paper 1. Okay, so following the diagram, it shows there's a semicircle ABC is where ABC is an arc of the semicircle, and there's a center O and the radius 8, so which means OC is 8 cm as well. Okay, angle AOD represents as theta radians. So there is a hypothesis for the first part. Okay, let the theta equals to 1, and it wants you to calculate the area of the sector BOC. So calculate this area, okay, the area of this region, right? So to calculate the area of a BOC, you must use the formula of the half r square theta, right? So what is the r? The r is 8, okay, 8 square. And what is a theta? It is not a theta. The actual theta is this angle subtended from A to B. But the angle that we want is subtended from B to C, right? So what is the radian form of the 180 degree, which is pi? So pi minus theta, right? Where theta is 1, following the hypothesis given in the part 1. Okay? So just press your calculators to get the decimal values of the area of the sector. So which is 68.5 cm square. Okay? So now the next part, the values of the theta is no longer 1. Anyways, it wants you to find the value of theta for which the perimeter of the AOB, okay, the sum of this and this is 1/2, okay, 1/2 of the perimeter of the sector BOC, okay. So means that this sum of these three lengths is the half of these three lengths, okay. So you can write it as perimeter of AOB equals to the 1/2 of the BOC. So what is the perimeter of AOB? Arc length of AB and the two radius, right? What is your perimeter of BOC? As it has a 2R as well, but with different arc length, which is SBC. Okay. So what is the SAB? Okay, we do have to state it is 8, since each term has a common term of the R, and in the end it must be cancelled because of the common terms, common factors for each term. So what is the arc length of the AB? Okay, which is R times theta. So which is R theta plus 2R, and with the half of the 2R plus what is BC? The arc length of BC is R pi minus theta, right? As we discussed just now, okay? For the angle, this is the pi minus theta, okay? So means that the complementary angles of two of these is a pi, which represents 180 degree. So as you can see that R, the R at the in the four terms can be cancelled because of common. So now you will have theta plus 2 equals to 1 plus half pi minus half theta. So interpret in the correct mathematical operations. So for this, move to the left hand side, which is 3 over 2 theta, and this is the pi over 2 minus 1. Okay, multiply 2 at both sides, so we get 3 theta equals to pi minus 2, and here it is, theta equals to 1/3 of the pi minus 2. Okay, so although the question from the part 2 does not have any requirements for you to put in the specific form, however, it is a good news because the question is not mandatory for you to live in exact form. Okay, so therefore you can live in either the exact form or in decimal form if you wish. So if you convert to decimal form, you will get 0.381381 rad. Okay, it is best for you to leave the angle units, perimeter, and area. Okay, to provide the clear details of your workings for the examiners. Okay, it is highly recommended for you to do that. So for me, I deem to live in the exact form to maintain its accuracy. Alright. Oh yeah, there is a new case of the theta for the third part. So it's fine for you to live in the decimal form. Okay, so let's move on to the third part. In the case where theta equals to pi over 3, show that the exact length of the perimeter ABC, okay, is 24 plus 8 is 3 cm. Okay, so how to get the perimeter of the semicircle? Perimeter of the semicircle, which is the arc length of the semicircle. What is the arc length of semicircle? Which is the r times pi, okay, plus the 2 times of the radius. Oh, sorry, it says that you need to find the triangle ABC, not the entire semicircle. So the question demands you to find the perimeter of this for the triangle ABC that I have two shape. Okay, so we need to find the segments of AB and BC, and we have the AC already, which is the twice of the radius, which is 16, 2 times 8. Alright, so that means you need to find what is the length of segment. Okay, you must use the cosine rule in order to get it. So to get the AB, you need to square root the twice of the r square, okay, following the cosine rule, minus the twice of the 8, the twice of the r square, cosine of the theta. What is the theta? Theta is pi over 3, right? Okay, make sure the angle units in your calculator must be in radians. Okay, don't forget to convert it before you make any mistakes because of the basic conversions. Okay, don't do the careless mistake. So coincidentally, the AB is 8. It's an integer and exact value. What about BC? Okay, BC just use the cosine rule as well, which is twice of the 8, just that you need to change the angle. Cos of the pi minus pi over 3. Okay, so which is 8 to 3. So you will now it's time for you to find the perimeter of ABC, triangle ABC, not the semicircle ABC. right, which is 8 plus 8 sub 3 plus 16, okay, which is 24 plus 8 sub 3 cm, and which is shown. Okay, verify your answers compared to the answer given from the questions. Alright, so yeah, that's the end of the discussion for this question. Okay, let's move on to the next question, which is the question 12. A past year questions from 9709, May June 2009, question 5 from paper 1. Okay, so referring to the diagram, it shows that there is a circle with center O, okay, and the circle is separated into two regions, R1 and R2, okay, restricted by the arc, each respective arc of the sector and the radius, okay. So don't misunderstood the radii OA and the OB, okay. Actually, in a circle there is a constant radius, right? So given that the perimeter of the region 1 equals to the length of the major arc, okay, so which means this sum of the two radius and the arc AB equals to the major arc of AB, right? So for the part A, prove that the theta equals to pi minus 1. So you have to use the informations that I highlighted over here, okay, use the relationships stated to obtain the answers over in the questions, okay. So the perimeter of the region 1 equals to the arc of the AB major, alright, AB of the R2, okay. So how to get the perimeter of the region 1, which is the twice of the radius, right? So let's label it as R, okay. The 2R plus R theta equals to the arc length. So how to get the angles subtended, the major angles AB subtended from A to B, which is 2 pi minus theta, because a complementary angle of a circle is 360 degree, which is 2 pi, okay. So you have R times 2 pi minus theta, okay. As you can see that there are common terms of R, you can cancel it away, you leave it as 2 plus theta equals to 2 pi minus theta. So you have 2 plus 2 theta equals to 2 pi, cancel the 2 for all terms, okay. You have 1 plus theta equals to pi, so you will get theta equals to pi minus 1, okay, and therefore shown. Okay, so move on to the part 2. Given the area of region 1 is 30 cm square, find the area of region 2 correct to 3 significant figures. So first, we have the known degree, we have the known angle, but we haven't determined the radius first. So use the information of this step of the questions to find the radius, hence find the area of region 2, okay, step by step. So you state that area of region 1 is 30. How to find? Half r square, what is theta? Pi minus 1, okay. So we have 60 over pi minus 1 and take the and this is your r square, okay. So you, instead of looking for the r, you do have to take the square root of both sides, because in the end you have to use the r square for the area of region R2, okay, since R2 is a major sector. So to get the area of region 2, you have to use back the formula of half r squared theta, just that the angle subtended is not theta, is 2 pi minus theta, alright. So you have half r squared 60 over pi minus 1 what is the theta? 2 pi minus pi minus minus positive 1. So just directly press your calculator. See how much you get. You will get 58.0 cm squared. Okay, that's the answer for the area of shaded region 2. Okay, thank you. Alright, let's move on to the next question, which is the question 13. It's a past year questions from 9709, May-June series 2010, question 7 and paper 1-3. So, referring to the diagram, it shows that there's a metal plate. Regardless of metal plate, we're just only focusing on its geometric, which is the incomplete circle with 2 removed segments. Okay, so which 2 shaded regions are identical since because of same radius. Alright, and given that the chart of this is 12. Okay, the reason of the same identical segment is not the radius, it's because of the same segment. Oh yeah, of course it's also because of the same radius as well as the chord in length. Okay, so for the first part, show that the angle DOE is 1.287, correct to 4 significant figures. So despite you neglecting the instruction over here, however, you have to leave your angle of DOE in exactly the same as the answer shown in on the questions. All right. So, how to looking for this angle DOE. So let's label it as the theta, right? Okay, theta equals to angle DOE. So you can see there's a triangle over here. Okay, there's an isosceles triangle. So the only way is to use the cosine rule. So what does the cosine rule state? It states that the length which is opposite to the angle 12 square, okay, the square of the length which is opposite to the reference angle equals to the sum of the other 2 lengths. Each of it must square it up, okay, which is 10 square minus the twice of the product of these 2 sides and the cosine of theta. Okay, so this is how it states, how it works. Okay, and carefully operate it and take the course without making the careless mistakes. Okay, but the question wants the angle must be in radians, so remember to convert the angle unit in your calculator to radians. Okay, to ensure you won't calculate it wrongly in degree. So yeah, eventually your theta must be 1.287, is exactly the same as the result shown over here. So therefore it's shown. Okay, so let's take a look at the second part. Find the perimeter of the metal plate. Okay, so what does it mean? It means that you need to find the perimeter of this geometric, okay, of this shape. So this is the main prompt does the question want to pretend. Okay, so how to get the perimeter of the metal plate? So you can draw a line over here, okay, where the line has the length of the 10, which is radius, right? So here is the 10 and 10. Okay, how to get the perimeter? You must get the arc length of both of these as well as the length of the chord. Okay, as you know that the angle AB, I mean the chord AB, is equal in length as the DE, which is 12. But how to get the angle alpha over here? Okay, let's say here is the alpha. So this is a straight line, or it's so-called collinear. Okay, when it comes to the collinear, the complementary angles of this must, sum of these two complementary angles must be 180 degree or pi. Okay, since the theta is in radian. So what are you going to do is alpha plus theta equals to pi. So what is the theta? Okay, and if you want, you may leave your theta values as the exact value, which is roughly 5 SF, which is roughly 1.28700. But eventually, it's almost the same as the answer stated over here. So instead, we just state the theta as 1.287 over here. So if you want to maintain its accuracy, yes, you may. Okay, the alpha is pi minus 1.287. Okay, let's assume the angle of alpha of this is an exact value, right? So how to find the arc length? We must use the formula of S equals to r theta. Okay, since the arc length of two of these are both identical, so it is convenient for us to calculate the perimeter of the metal plate. So perimeter of the metal plate is 12 plus 12 plus twice of the r theta. Okay, the r is 10, right? And it is not a theta, it is alpha. Okay, you want to because you want to find the arc length of this respective to the angle alpha over here. So plug in the values of the alpha and you should get the answer of the perimeter numerically. So you will get 61.1 cm. That's the answer of the perimeter. Okay? Okay, so let's move on to the next part. Find the area of the metal plate. So how to get the area of metal plate? Okay, if you are good in visualizations, it's actually the same theory as the previous question that we have discussed. So here is the area of the whole circle, right? But how to get the area of this? As I said before, you must remove away the two segments, which means, okay, which means the area of the metal plate equals to the area of the whole circle minus the twice of the angle of the area of the segments. Okay, since the segments are both identical. So how to find the area of the entire circle, a complete circle, which is you can use half r squared theta, but instead we just state pi r squared. Okay, this one you should learn before in your secondary school. And what is your angle of area of a segment, which is you must recognize this formula, okay, which is the half r squared theta minus sine theta. Okay, why does it show sine theta? Because it follows the sine rule. Okay, the area of a scaling triangle, but in terms of the sine function. Alright, so as the reminder again, remember to convert the angle units in your calculator to the radian before you perform the calculations for these workings. So the r is 10. Okay, and this you may cancel out. And what is your theta, okay, respective to this angle. Okay, you want to find the area of a segment, you must follow its opposite angle, which is theta. Alright, so which means you don't have to convert it again. So here it is, where the theta is in radians. Alright, now then press your calculators to get the answer. So by right you should get 281 281 cm squared, okay, in three significant figures. Alright, so that's the end of the discussion for this question. Let's move on to the next question, shall we? Alright, let's move on to the last questions. Question 14, okay, among the exercises for chapter 4. So this is the past questions from 9709 October November series 2010, question 8 from paper 1-3. So referring to the diagrams, okay, it shows that there's a rhombus ABCD. So rhombus is quadrilateral, where points P and Q lie on the diagonal AC. So here is the diagonal AC, such that BPD is an arc, okay, as well as the arc BQD. Alright, with a center C for the arc of the BPD, okay, and the center point A for the arc of the BQD. Alright, so each side of the rhombus has a length 5 cm, okay, so here is the 5 cm, is also the radius, okay, the radius of the arc, I mean the radius of the sector respective to the arc. And the angle, where the angle BAD is 1.2 radians, so here is the angle BAD 1.2 radians, so if you divide by half you will get 0.6 rads, each of these respectively. So for the first part, find the area of the shaded region BPDQ. So how to get the area of shaded region? So first thing first, you need to draw an axis of symmetry line, okay, so as you can visualize that there are two segments. Alright, so how to get the area of the shaded region? It's just basically the twice of the area of the segments. Okay, so why do the two segments are identical? Why do two segments have the same I mean, why are the two segments are identical? Because they have the um, same radius as well as the length of the chord. Okay, so what is the formula of area segment? Which is half r square theta minus sine theta. Why sine theta? Because it derives from it is derived from the sine rule. Okay, the area of the triangle, but with sine rule, right? So just imply the formula inside your workings, and the radius is 5. So state it 5. And what is your angle? Okay, the angle is 1.2 minus the sine of the 1.2. So cancel the 2 out. Just use your calculator and press. Okay, so make sure to convert the angle units in your calculator to the radian form, okay, to avoid careless mistake. So it's just basically 5 times 1.2, the bracket of 1.2 minus sine 1.2, and there you have it, which is 1.34 cm squared. I think I have to recalculate again. Yeah, that's correct. So as you can see that the first part is indeed direct. However, for the second part, it is very hard for you to visualize and solve for the second part. Okay, because the second part asks you to find what is the length of the PQ. So let's erase again. Erase clearly. And I need to explain some workings with the visualizations for your understandings. Okay, to get the length of PQ, what should you do? So, given that BC is a 5, okay, 5 cm is the radius. So here is the 1.2. If you divide by half, you'll get 0.6 each. Right? And next you can draw a line. So this line is the chord of the segment. Right? For the 1.2, for the angle subtended of the 1.2 radians. But for 0.6 radians, the segment should be like this. Okay, let me change the color to like pink color. All right, for your understandings. Yeah. So, how to get the length of PQ? Okay, first we need to looking for what is the length of AC first, and then deduct away the AP and the QC. So what have you spotted? You can spot that the length AP and the length QC are exactly the same in length. Okay, because of they have the identical segments. Right? They have the identical segments. So I hope you understand what am I visualizing over here. Okay. So how to get the length of AC? Okay, to avoid confusion, let me separate the geometrically one by one. So first you can obtain a triangle that inscribes inside the rhombus, right? When you divide by half. So here is the ADC. Okay. So focusing on this triangle first. So as you can see that it is an isosceles triangle because of the isosceles triangle has two sides are same in length, following its property. Okay. So which means that this angle, this obtuse angle is pi minus 1.2. Why 1.2? It's because pi is 180 degree minus the twice of this. Okay? Minus the sum of these two angles. So since this is 0.6 as well as here, so therefore this angle must be pi minus the twice of this. Okay? Because these two angles are identical. So you can state that the angle of the D is pi minus 1.2 radians, of course. And yeah. Okay. So here is your 1.2 radians, right? But what rules I can use? You can use sine rule or you can use cosine rule. Just that cosine rule is quite troublesome because it involves the quadratic equations. Okay? And this might humble your score. So don't do that. Think it simple. So let's apply the sine rule to looking for AC. So what does sine rule state? It states that the AC the ratio of a side that is over the sine of its opposite angle, which are equal to each other. Okay? So, which means, following the sine rule, the length of AC divided by sine of its opposite angle, which is sine 1.2, equals the 5 over the sine of 0.6. Okay? And now you will get what is the AC. If you are not able to leave it as the in terms of sine, you can leave in decimal values of AC. Just that you need to leave it as 5 significant figures if you want to maintain accuracy. Okay, so by right I should get 8.2534. Okay, in cm. Alright, so what's the next step? The next step is oh, sorry, I think I made a careless mistake. This angle should not be 1.2, it is pi minus 1.2. My mistake. But anyway, eventually it will get the same value by right, because of its reference angle. So it still remains the same decimal value. Okay. So how to get the length of the AP? So remember that you have obtained AC is 8.2534, right? So if you want to get the AP, you should recall that this is the radius of 5. If you turn following the arc, so you must aware that PC is the radius, which is 5. So, and also you need to recall that the length of AP equals to length of QC. So therefore, how to get the AP, which is 8.2534 minus the radius. So what is the radius, which is 5? So how much will you get? Which is 3.2534. So here is the AP, and recall that AP equals to QC because of their respective identical segments. Alright, so now you have the length of AP as well as the length of QC, since they are the same. So therefore, how to get the PQ? The PQ equals to the length of AC minus the twice of the AP. So what is the AC? AC is 8.2534. And what is AP? 3.2534. So now use your calculator to calculate to obtain the final answer. So you will get 1.75 as the final answer. Okay. So yeah, that's all for the discussion of this question, as well as the entire exercises for chapter 4. So thank you. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.